Good morning, friends. Welcome to this neural anatomy classes. So please do subscribe to my channel to get the new videos of neural anatomy, and just ring the bell so that you will get the notification whenever I upload any new videos about the neural anatomy classes. Okay, let us move to the today's class is the structure of neocortex. So we must know the structure of neocortex before we explore the interior of all the cerebellum, thalamus, and every part of the brain. Okay, so coming to this structure of the neocortex. So the neocortical gray matter, it is varies in thickness. So 1.5 mm to 4 mm in the thickness. So it is thick over the gyri and is thin over the sulci. Then coming to this, it is according to the Brodmann, the scientist. So the cortical gray matter presents horizontal lamination and consists of six superimposed layers. Remember, six superimposed layers. So this laminar concept is broadly retained by the neurobiologists as a conventional dogma. The cortical neurons are of four basic types. So let us see the four basic types of the cortical gray matter or the neocortex. So here we can identify four different type of cells: pyramidal cells, stellate cells, cells of Martinotti, and horizontal cells of Castle. So let us discuss about these cells, what is the shape of these cells, and how they are present. Okay, so coming to these different shapes of the cells. First, I just want to explain you about these pyramidal cells. So these pyramidal cells, they are almost 5.5 billion in number. Okay, so what we are discussing in the cortical gray matter. So where the gray matter is present at the surface, you can identify the gray matter. In the gray matter, we can identify four different cells. They are pyramidal cells, cells of Martinotti. Then you can identify stellate cells. Here you can see the stellate cells. Then pyramidal cells. These are the pyramidal cells. So pyramidal, stellate, cells of Martinotti, and other cells are horizontal cells. Horizontal cells. I will explain you all this. Okay, so first we will see the pyramidal cells. It is about 5.5 million in number. 5.5, sorry, billion in number. Okay, each pyramidal neuron, it's have a body, apex, and the base. Okay, it's having body, apex, which is projecting towards the surface, base is projecting lateral. Okay, so transversely the base is projecting. So that is about the pyramidal cells. Just yes, that is about the pyramidal cells what we have seen now. Okay, so apex is projecting towards the surface and base and the basal dendrites. Apical dendrite is thick. Apical dendrite is thick, whereas the basal dendrites are thin. Okay, so that is the structures you have to remember. Then coming to the stellate cells, here you can identify the stellate cells. It is also called as granule cells. So these granule cells, they belongs to Golgi type 2 neurons. The cell bodies are small and the dendrites make synapses with the afferent projection fibers. If you just look at these pyramidal neurons, they are forming synapse with the Martinotti cells and they are forming synapse with the other pyramidal cells. Okay, and also they are forming synapse with the efferent cells. Okay, and whereas this stellate cells, they are forming synapse with the pyramidal cells and they are also forming synapse with the afferent cells. Okay, they are forming synapse with the afferent cells. So this red color one, yes, here you can see that this blue color one showing the afferent fibers. Okay, afferent fibers. Whereas the red color one I'm showing you the efferent neurons. So the stellate, they're forming synapse with the afferent projection fibers and with the collaterals of pyramidal axons. So the axons of stellate cells, the axons of stellate cells. What happens to the axons of stellate cells are they form ascending and descending branches and establish synapses with the dendritic spines of pyramidal neurons or other interneurons. Okay, so thus organizing the columnar functional unit. So just remember, these are the satellite cells which are forming synapses with the pyramidal neurons and afferent neurons. Then coming to the cells of Martinotti, here you can see the cells of Martinotti. They are multipolar small neurons, multipolar small neurons. Okay, they're located in the most of the layers of the cortex, but more so in the laminae 6. What is laminae 6? I let you know, I will show you. So they possess the smaller dendrites. They possess smaller dendrites over here, and then they which run vertically outwards and ramify in the superficial laminae of the cortex. So here you can identify the Yes, here you can see the dendrites of the Martinotti. They're extending upwards and reaches to the superficial layer of the cerebral cortex. Then coming to the horizontal cells of Kazan, here in this first layer you can identify H shape. This is nothing but horizontal cells of Kazan. So they are located in the lamina 1 and their neurites extend tangentially and integrate numerous columnar units of the cortex. Okay, so these things you remember. Along with that, we can identify so the reciprocal connections between cerebral cortex and thalamus, cortico-pontocerebellar, cerebello, thalamocortical, and cerebral cortex to basal ganglia, then thalamus and back to the cerebral. So there are so many fibers which are present inside in the cerebral cortex. The fibers are the afferent connections which are extending from the thalamus. Okay, and then they may extend into the pons called as cortico-pontocerebellar fibers. They are afferent fibers. So, along with that fibers, you can identify these neurons which are present in the cerebral cortex, gray matter. So, let us discuss about one by one. So, these are the molecular lamina structure which we can identify. So, it consists of horizontal nerve fibers. So, coming to this laminae 1, what are the structures present in the laminae 1? So see the laminae 1, what are the structures we can identify are, we can identify occasional horizontal cells of Kazan. Okay, occasional horizontal cells of Kazan. We can identify horizontal fibers. These are nothing but the horizontal cells of Kazan. Okay, and then the fibers are derived from the apical dendrites of the pyramidal cells. So I have shown you the pyramidal neurons. The new pyramidal neurons apex, from the apex we can identify the dendrites are extending and reaching to the laminae 1. Okay, laminae 1. Then we can identify, yes, here you can see that horizontal fibers extending from the apical dendrites of pyramidal cells and axons of stellate cells. So stellate cells, they are also called as granule cells. The axons of the stellate, they are extending into this first layer called as lamina 1 or molecular layer. And even the Martinotti cells, the neurites of horizontal cells of Castle, then afferent projections from the thalamus. So they are called as thalamocortical fibers. They are afferent projection fibers. So these are the structures we can identify in lamina 1. Then moving to the lamina 2. So this lamina 2 is called as outer granular layer. This laminae is packed with the numerous stellate or the granule cells. Here you can identify these are all the granules. These granules are also called as stellate cells. Okay, so granular cells it is also called as stellate layer. So in this lamina 2 is traversed by afferent and efferent projection fibers. These are the fibers which we are identifying. They are nothing but afferent and efferent projection fibers. Then moving to the components, yes, here you can identify less pyramidal neurons. Then coming to the lamina 3, it is predominant occupants of pyramidal cells. Here you can identify these are all the pyramidal cells. So here you can see the apex and this is the base of the pyramidal cells. So from the apex, apical dendrite is thick and is extending upwards and is crossing the second laminae and reaches to the first layer, first laminae or molecular layer. Okay, so that is about lamina 3, and we can identify the stellate neurons also. All the stellate neurons also we can identify these are nothing but the stellate neurons. Then the small pyramidal cells lie in the superficial laminae. In this third laminae, small neurons are present in the outer zone. Suppose if we just separate this lamina 3 into two zones, outer and inner zone. Outer means which is present towards the surface, inner zone means which is present towards the base. So at the upper part or outer zone, we can identify small pyramidal neurons are present. At the base, we can identify the big pyramidal neurons, okay, medium-sized pyramidal neurons, which are present towards the base. Okay. Then coming to the lamina 4, in the lamina 4, it is also called as inner granular layer. Inner granular layer. It is beset with the densely packed stellate neurons. You can identify very densely packed stellate neurons. And the inner zone of this layer is traversed by tangential fibers of outer band of bilateral derived from the association and projection fibers. So association fibers means, so suppose from one gyri of one cerebral hemisphere to the same cerebral hemisphere with different gyri. Suppose if you take the superior frontal gyrus, the neurons which are present in the superior frontal gyrus, the fibers extending downwards, that is reaching to the inferior frontal gyrus or middle frontal gyrus. They are called as association fibers. Whereas the projectional fibers, they are extending downwards and reaches to the other areas of the brain. Means it may reaches to the pons, it may reaches to the medulla, it may reaches to the cerebellum. They are called as projection fibers. So these two types of fibers which are present in the lamina 4. Then coming to the lamina 5, it is called as the inner pyramidal layer or ganglionic layer. So here we can identify the medium and large pyramidal neurons. Medium and large pyramidal neurons, which we can identify over here. The large neurons are also called as giant pyramidal cells of beds. Giant pyramidal cells of beds we can identify in the fifth layer, and almost it does not exceed to 35,000 and pyramidal cells neurons are present in this lamina 5. Okay, then same here also you can identify the tangential fibers of inner band of bilateral close to the outer zone, that is about lamina 5. Then coming to the lamina 6, it is called as polymorphous layer or pleomorphic layer or this polymorphous layer or pleomorphic layer. It is contains of multipolar neurons. Okay, modified pyramidal cells, and we can identify cells of Martinotti. We can identify over here, and there is cells of Martinotti with axons projecting vertically. So these are the axons of Martinotti neurons. Then corticopetal and corticofusal and the projectional fibers, they are present in this lamina 6. So that is about the laminar structure of the cerebral cortex. Okay. So other functional aspects are the pyramidal cells and the spiny stellate cells. They contain mostly excitatory neurotransmitter like glutamate, aspartate. So the greater majority of non-spiny, non-pyramidal neurons cells use GABA, means gamma aminobutyric acid, as the principal inhibitory neurotransmitter. So other things we will study in the physiology. So the rest of the things I am going deep, and tomorrow I am going to discuss about the motor areas of the cerebral cortex. So if you have any doubts, please contact me freely. Thank you.